This video will be focusing on solving simple rational equations. All you're going to do here is essentially simplify one side of the equation that has the rational expression, and then we're going to solve for x. I'll show you what I mean. Starting with example 11. If I'm going to try to simplify this rational expression, I need to first factor the numerator and denominator if at all possible, cancel out common factors, simplify, and then solve. If I were to look at the numerator of my first term here, I have x squared minus 9. Hopefully you're able to recognize at this point that this is a difference of two squares, where a would be x and b would be 3, because x squared gives me x squared and 3 squared gives me 9. So the factored form here is x plus 3, x minus 3. If I rewrite that as x plus 3 times x minus 3, I now need to take a look at the denominator. X plus 3 cannot be factored further, so I'm just going to go ahead and rewrite it. Remember, this is x plus 3, the expression, so if you want to put parentheses around that, that's perfectly fine. And we need to keep in mind this is being set equal to 7. Hopefully you've noticed as well that the x plus 3's cancel because they're common factors, which means I'm just left with x minus 3 equals 7. At this point, we should easily be able to solve for x. To get x by itself, I'm just going to have to add 3 to each side, giving me x equals 10. Now, it does say in the directions to check your solution. There's two ways that you can do this. The first way to check is you could take 10 and you can plug it in the original equation. So I could plug it in and have 10 squared minus 9 over 10 plus 3 equals 7. Or you can ask yourself, when will the function be undefined? Remember, a function is undefined when the denominator is equal to 0. So when the original denominator is equal to 0, that would show you what x cannot equal. I'm just going to set x plus 3 equal to 0 and solve by subtracting 3 on each side. So that means when x equals negative 3, the function will be undefined. So x cannot equal negative 3. Well, 10 is not negative 3, so hey, it should work. It's up to you which method you'd like to do. I would like you to keep practicing when a function is undefined, so I recommend that you do it this way. Again, the conclusion was because 10 is not negative 3, it is a solution. It should work. Let's try example 12. So for example 12, once again, we're going to simplify this rational expression and then solve for x. When simplifying, the first thing you should do is try and factor the numerator and denominator if at all possible. The numerator is a trinomial where a is equal to 1, so I can go ahead and just use guess and check. The factors of 4 are 1 and 4, 2 and 2. Because it's negative, I know I'm going to be using different signs, so one positive, one negative, in order to get the middle term of a positive 3. So if I want a positive 3, it should be a positive 4 and a negative 1. Meaning the factored form is x minus 1, x plus 4. The denominator, x minus 1, cannot be factored any further, so I'm just going to rewrite that. And remember, it's set equal to 5. Hopefully you notice that we do have common factors of x minus 1, so we're going to cancel those out, and I'm left with x plus 4 equals 5. At this point, we can easily solve for x by subtracting 4, giving me x equals 1. When we go to check, we can either plug 1 back into the original equation and see if that works, or we can just check and see when the function is undefined. So let's say I want to practice this, so I'm going to continue that. A function is undefined when the original denominator is equal to 0. Undefined when original denominator equals 0. So I'm going to set x minus 1 equal to 0 and solve. That means it is undefined when x equals 1. So x cannot equal 1. Well, it just so happens we solved and got 1, so this is an extraneous solution. Remember, something is extraneous when it's a false solution. It doesn't really work out. So because we've ruled out our only possibility as being extraneous, there actually is no solution. And I want to go back and show you. If we would have plugged 1 back in, notice how in the denominator we would have had 1 minus 0. Any number over 0 we've described in the past as undefined. That's why it's no solution. I would like you to use examples 11 and 12 to help you solve 13 and 14. And when you are ready, hit play to check your work. Hopefully that went okay for you. For example 13, only the numerator was factorable. Hopefully you noticed that this is a difference of 2 squares, where a is x and b is 5. So the factored form is x plus 5, x minus 5. The denominator was not factorable, and it was set equal to 14. So the x minus 5s were common factors. They cancel out. I'm left with x plus 5 equals 14, which we are now able to solve for x. You get x equals 9. If I were to check my solution, you have 2 options. You can plug 9 back into the original equation and see if it works or not, see if we really do end up getting 14. Or we can just find when the original denominator is equal to 0, and if it's not that number, it should be a solution. So just by looking at this, I can tell it's going to be undefined when x is 5, a positive 5. Because x minus 5 equal to 0, you would add 5 to each side. This one is undefined. So because 9 is not 5, that means, hey, that should work. It is a solution. When you are trying example 14, only the numerator was factorable. The denominator was not factorable. It was a trinomial where a is 1. So that means I can just do guess and check. The factors are 1 and 10, 2 and 5. I need to use different signs to get a positive 3. So that means it's x minus 2, x plus 5. And it was equal to 7. X minus 2 is a common factor, so I just have x plus 5 equals 7. Subtract 5 from each side, I get x equals 2. Now we need to check and make sure that this really is a solution, because we discovered sometimes it can be extraneous. You can check by either plugging in the 2's to see if it really equals 7, or you can just see when it is undefined. Remember, it's undefined when the original denominator, so in this case, x minus 2, is set equal to 0. So x minus 2 equals 0 gives me a solution of 2. So x cannot equal 2, which just so happens to be the solution we found. So that means this is really extraneous. It's a false solution. And because we ruled out our only solution, there's no solution. Or like I said, had you plug the 2 back in, you would end up with something over 2 minus 2, or some number over 0, which we know is undefined, so that doesn't work.